friends, my name is Asma Srivastava and today I am going to discuss with you this question of the lead code. So let's start. The heading is the minimum subarray length with distinct sum at least k. From the heading itself, you can estimate that you have to find out the length of the minimum subarray, and in that minimum length subarray you have to find out the sum of the distinct elements, and when you will calculate the sum of those distinct elements, their total sum should be at least k, that is greater or equal to k. So let's read the problem discussion. Let's read the problem statement. You are given an integer array nums and an integer k. Okay. Return the minimum length of the subarray means, for all possible subarrays you have to find out the minimum possible subarray length whose sum of the distinct values present in that subarray. Each value counted once is at least k. If no such subarray, you have to return the -1. So the problem is, for any given subarray, firstly you have to find out uh, how many unique elements are there in it. Like in this case, you can find out there are a single frequency of 2 and two frequency of the 3. So if you find out the distinct sum, it would be 3 plus 2, that is 5, and it is also a valid subarray. So before moving to the actual implementation, let's have an intuition of the problem. So you can basically bifurcate this problem into the two parts. The first one is the length of the subarray, and the other one is that you have to find out the sum of that subarray. Okay, so first of all, let's focus on the sum of that subarray. Okay, so for now, consider that you have to find out any subarray in which the sum of the distinct element is greater or equal to k. Okay, so the intuition is, uh, let's have a look on the constraints. As you can see that all the elements are positive. So the first point should be, like, if you have taken any subarray, if the sum of distinct elements in that subarray is already greater than k. So if you increase the length of the subarray, then in that case also you will have a valid subarray. Valid in the sense of you have a subarray in which the sum of elements or sum of unique element is greater than k. So the first thing is, since all the elements are greater than k, so if you have any subarray in which the sum condition is already satisfied, then if you increase the window size of that subarray, then that increased subarray will also be a valid choice. So this is the first intuition. Let's write it down. Like, if subarray satisfy condition that sum of distinct element sum of distinct element already greater than k, then if you increase uh, its size, then sum will also be greater or equal to k, or greater or equal to sum of current subarray. Okay, so this is the first intuition. Now let's have a look at the length part. You have to find out the minimum length of the subarray. Okay, so as I already said that if you have a subarray that is valid, then for that valid subarray you will have some length. Like, this might be a valid subarray, and the length of that subarray is 3. In this case, the subarray I am considering. So you have to find out the minimum length of the subarray. So my intuition is like if you have any search space, like uh, let's say you are at a you are let's start with the linear approach. Like let's say let's take the example. Let's start with the very beginning. Like let's say we will consider that the minimum length of the subarray would be 1. So it might be possible that the minimum length can be 1 or it cannot be 1. So it will depend upon when we will be calculating the sum of all possible subarrays of that length. So let's start with the all possible lengths, like we can have the length 1, length 2, length 3, length 4, and like that. And we can have up to n length. And this might also be possible that when you take the sum of the whole array, then also the total sum of the distinct value is not up to k. So in that case, you can simply return the -1 value. So my consideration is let's take all possible lengths and let's start with the minimum possible. Like then we will increment it one by one, like 1, 2, 3, 4, and like that. So you can think in let's go to the blackboard. So what I want to say that let's say this is the length you have. You are considering the length of 1, 2, 3, 4, 5, 6. So this is the all possible lengths we will be considering. So we will firstly take the 1, then 2, then 3, then 4. And if at any point we are able to find out any subarray in which the sum of distinct element is at least k, then it is a valid length. And once you find out, there is no need to further move forward. So this is the first point. Like you can bifurcate the whole solution space into the two parts. Like there is a partition. Before that, all possible lengths have all possible length will not give you a sub-array in which the distinct sum of distinct element is at least k, while in the other part you have you can find out at least a single sub-array of that length in which the sum of all elements is sum of distinct element is at least k. So from here you can think of the binary search. Like you have the solution space, you will move to any point, and for that point you will check that is there any like is there any sub-array in the given nums which has the sum at least k, and if that is a valid choice, then you will search in the smaller space, and if this is false, then you will search for a larger subarray. So this way you can bifurcate the solution space into the two parts. So for now, let's start the coding on this problem. So let's consider all the lengths. Like I can have the length 1 or I can have the length up to n. And n is what? N is nums dot length. And let's consider answer is -1. Uh, the case when there is no subarray, that is valid. And I will be returning answer. Now, our conventional binary search approach, or for now, let's start with the basic linear approach like uh, I is equal to left, I less than equal to right, I plus plus. And if is valid, nums I, then you will be returning that length. So this is the linear approach. Okay, but for now I am starting with the binary search itself. So let's take the mid pointer while left less than equal to right. Finding out the mid pointer, right minus left divided by 2. So if is valid, what nums mid, then you have a valid answer. So you will initiate the nums with the mid value, and you will try to explore a length which is more smaller. So your right pointer will move down. And if it is not valid, then you will move the left pointer to the mid plus one. When you will be out of this while loop, left will be equal to right. So again have a check that if there is any valid sub array, and if that is the case, then answer will be left. So now the point is, how will you find out whether a given sub-array is valid or not? Like you have the nums and the length, let's say length. So you have to check all possible lengths. Let's say length is 3. Let's say length is 2. So when length will be 2, you will be considering this subarray. Thereafter this subarray and this subarray. And if while you will be considering this one, you will have to take into the consideration the unique elements in that subarray. And if the total sum is greater or equal to k, then you have found out a valid subarray. And let's also consider take the k value in the parameter in total sum. Least sum you can also say. So since we have to find out the sum of distinct elements. So whenever we think of distinct, the first thought we have is of the HashMap. So I am using the HashMap. I have also a approach in which I am using the iterative segment tree. If you like the approach, then you can explore this solution of mine. Let me show you my solution to you. Uh, so here I have posted the solution in which I am using the iterative segment tree. It is a very good approach. If you want to have a dedicated video on this, then just say about this in the comment, and I will upload a dedicated video on this iterative segment tree and for this problem also. So now let's move to this problem. So I am taking the hash map, and now first take into the we also have to consider the running sum as well. So firstly we will be taking the first sub array of that length. So if this is the first time we are encountering any value contains key nums of I equal to false, so you will be updating the current sum with this value, and you will be putting it also in the map, else you will be updating its frequency. So this is the first sum array of the specified length. And if our current running sum is greater or equal to total, then we can return true. So now consider the other length as well, other sub arrays of that length, I plus plus. So let's say length is 2. So from this for loop, you will have traversed all the elements in this. So when you will move I to this pointer, then you firstly have to insert this element and you have to remove the element present at outside of this subarray. Like if you are here, then you have to remove the element that is out of this subarray. So let's have a look. If map dot get nums of I minus length equal to 1, like you have only one occurrence of that element that is out of the bound, so you will be removing it from the current sums as well. And map dot remove nums of I minus length, uh, and else if the occurrence of that element is greater than 1, then there is no effect in the sum, as the current value will have uh, at least one occurrence of that element that is going to be removed. So no impact on the current, but just update the frequency of that element in the map itself. Dot get nums of I minus length minus 1. So this is the removal part. Now let's insert the new element. First have a check that is it already contained in it or not. Contain key nums of I. If it is already present, then just update its value. Uh, Else if it is not there, then you have to update the current as well, and you have to initiate its frequency by 1. So this is the approach. And if at any point you have the current lending sum greater or equal to total, then you can simply return true. And if you are unable to find any subarray of at least some k, then you can simply remove it. So this is the approach. Now let's try to run this one. Let's exit the full screen mode. Okay, so let's try to run this one. Uh, Let's wait for a few seconds. What is this? You have to put it here num slot length. And one more error. Here should be map dot put, not map dot get. So let's run this one. You can explore this solution of mine, in which I have used the iterative segment tree. If you love the efforts of mine, then just have good comments in the comment box. Thank you.